Welcome to today's video, where we're going to explore an interesting problem in the world of computer science, finding the smallest positive integer in a sorted array. This might seem like a simple task, but it's actually a fundamental concept that has many real-world applications. Whether you're working on data analysis, algorithm design, or software development, understanding how to efficiently search and manipulate arrays is crucial. In this video, we'll take a deep dive into the concepts and steps involved in solving this problem. We'll break down complex ideas into simpler parts, using examples and analogies to help illustrate key points. By the end of this video, you'll have a solid grasp on how to approach this problem and be able to apply your knowledge to various scenarios. So let's get started. Imagine we have a sorted array of integers, and our task is to find the smallest positive integer within that array. Sounds straightforward, right? But before we dive into the solution, let's consider a few things. What if the array contains only negative numbers or zeros? What if it's empty? We need to account for these edge cases. One approach to solving this problem is to iterate through the array from left to right, checking each element to see if it meets our criteria, being positive and smaller than any previously found positive integer. However, as we explore the array, we might encounter some challenges. For instance, what if the smallest positive integer appears early on in the array? We wouldn't want to continue iterating through the entire array unnecessarily. To overcome this, we can use a simple yet effective strategy: maintain a variable that keeps track of the smallest positive integer found so far. As we iterate through the array, update this variable whenever we find a smaller positive integer. This way, we ensure that our solution remains efficient, even when dealing with large arrays or edge cases. Let's consider an example to illustrate this concept further. Suppose we have the following sorted array with 3, 2, 0, 1, 5e. Using our approach, we'd start by initializing our variable to a value representing no smallest positive integer found yet. As we iterate through the array, we'd encounter the first positive integer, which is 1. We update our variable to reflect this new information. Continuing with the iteration, we find that there are no smaller positive integers in the array. Therefore, when we reach the end of the array, our variable would still hold the value 1, indicating that it's indeed the smallest positive integer within the given sorted array. To summarize the key points from today's discussion, when solving the problem of finding the smallest positive integer in a sorted array, consider edge cases such as arrays containing only negative numbers or zeros. Use a variable to keep track of the smallest positive integer found so far and update it whenever you encounter a smaller one during iteration. This approach ensures an efficient solution that handles various scenarios effectively. Finding the smallest positive integer in a sorted array might seem like a simple task at first glance. However, by considering edge cases, utilizing variables to track our progress, and iterating through the array with a strategic approach, we can develop an efficient solution that tackles this problem effectively. If you have any questions or would like further clarification on any of the concepts discussed today, please leave them in the comments below. Your engagement is invaluable in helping us create content that's both informative and enjoyable. Don't forget to give this video a thumbs up if you found it helpful, and consider subscribing for more content related to computer science, algorithms, and problem-solving strategies. We're always looking forward to exploring new ideas and topics with our viewers. Thanks for watching.